Hello friends, welcome to the video lecture series of differential equation. In previous lecture, we discussed about exact differential equation. In exact differential equation, there is a standard format for solution and the integrating factor is also required. There were many equations which were not exact differential equation, but we converted those differential equation into exact differential equation using integrating factor. And there are various formulae to find out integrating factor. Now, in this lecture, we are going to discuss the very important topic of first order, first degree differential equation, that is linear differential equation. Then what is linear differential equation? An equation of the type dy by dx plus py is equal to q is called linear differential equation. I repeat, dy by dx plus py equal to q, where p and q are functions of x or constant. Here we have y, and if you look at it, it is observed that there are three terms are there: first term, second term, and third term. Terms are separated by plus, minus, or equal to sign. So where p and q are constant. If equation is of this type given to you, then integrating factor is required to be found. So what is integrating factor? E to the power integration of p with respect to x. E to the power integration of p with respect to x, that is integrating factor. And once you get this integrating factor, then we can write solution for linear differential equation. Y multiplied by integrating factor is equal to integral q multiplied by integrating factor, and this thing we have to integrate with respect to x plus integration constant. Okay, this is the solution format for linear differential equation of this type, dy by dx plus py equal to q. So this thing you have to remember, that this standard format for this type of differential equation may be asked as an MCQ. This may be asked as an MCQ. Then integrating factor may be asked as an MCQ. Integrating factor is what? E to the power integration of p with respect to x. Now, very quickly, some problems we are going to solve. First problem, dy by dx plus y cot x is equal to sin 2x. Now, if you look at this differential equation of the type, dy by dx plus py equal to q. Dy by dx plus py equal to q. And what is the restriction on p and q? P and q must be functions of x or constant. That is important. Where here p is what? Here p is cot x and q is what? Q is right hand side of the standard differential equation is sin 2x. And if you look at this p and q, the p and q are functions of x. If equation is of this type and p and q are functions of x, then we can say that is the linear differential equation of dy by dx plus py equal to q. And I am calling this as a type 1 linear differential equation. Now, once this is the type is recognized, now integrating factor I am going to find. Integrating factor is what? E to the power integration of p, and that integration we have to carry out with respect to x. This equals integration of p. P is what? Cot x. And integration of cot x is what? Log of sin x. Integration of cot is what? Log of sin x. This equals e to the power log of sin x will be sin x. So this is integrating factor. This integrating factor may be asked as an MCQ. This differential equation you will be given. The integrating factor for this and this differential equation is dash. I mean, this will be the correct answer for integrating factor. This will be asked as an MCQ. So once you get integrating factor, Then use standard format for solution. What is the solution format? This is the solution format for linear differential equation is of this type. But this formula, once again, I am not writing here. The solution of the differential equation, solution of given differential equation is what? Y multiplied by integrating factor. What is integrating factor? Sin x is equal to integral q multiplied by, what is q? It is sin 2x. And integrating factor is what? Sin x. And this we have to integrate with respect to x. Plus c we can put, or in the last step you can put plus c. It is also. Now, it remains to find integral of right hand side. On the left hand side we don't have integral. Once you solve integral of right hand side, then you will get the final solution. The y multiplied by sin x, this left hand side will be as it is because integration is not present. So this elementary integration you must do. Okay, this type of integral you have evaluated in previous years. Sin 2x into sin x. So you can use your way to solve this integral. You can use the formula of sin a into sin b, trigonometric formula, and you can solve it further. Or this sin 2x and sin x. So here argument is 2x, here argument is x. So I am going to bring this argument same. The sin 2x can be written as 2 sin x into cos x. This is sin 2x and sin x is as it is. This integration you can solve by your way also. The 2 is outside of integral. Sin square x, sin into sin and cos x. We are integrating with respect to x. Now, the arguments are same, means sin x is the argument here in sin, x is the argument in cos. Now evaluate this integral. If you look at this integral, this function very carefully, this is the power function, sin power 2. And derivative of sin is present in the multiplication. In that case, you can directly use, or you can substitute sin x equal to t and you can solve it. Okay, but I will recommend you to use this direct formula now. See, integral of f to the power n f dash. The derivative is present in the multiplication of f to the power n. Then its integral will be what? F power n plus 1 by n plus 1. Here f to the power 2 into f dash is derivative of sin. It will be what? 2 times f to the power n plus 1. You can directly write 3 also. This divided by 3. This formula I am using. Plus integration constant in the last step you can put c. Now this is equal to y sin x. Okay, this I have not carried out this y sin x in each and every step, because if there is equal to sign, it is understood that this y sin x is carried forward. Now 2 by 3 sin power 3 x plus c. Okay, this is the solution to the given differential equation. In online examination, so you may be asked to find out solution where differential equation and integrating factor you will be given. There are 2 parts. First part is to find out integrating factor and second part is to find out solution. So if you may be asked to find out integrating factor, or if differential equation is given, integrating factor is given, so you will be asked to find out general solution also as an MCQ. Now, next problem, the same problem. Cos square x divided by dx plus y equal to tan x. This we are going to solve. So if you look at this differential equation, this observation is very important when you solve differential equation. First term, second term, third term. First term containing dy by dx, second term containing y only, right hand side is what? Function of x. But this unwanted cos square x is present. We don't want cos square x. So you can divide by it by cos square x. Or you can divide it by cos square x or multiply by sec square x. Multiplying by sec square and dividing by cos square is the same thing. in order to reduce step, yes, I am multiplying it by sec square instead of dividing cos square. Now, sec square into cos square is 1. This differential equation becomes dy by dx plus sec square x multiplied by second term and sec square x multiplied by third term. See, we brought into standard form now. Now this differential equation is of this type. Dy by dx plus py equal to dy by dx plus py is equal to q. But you have to ensure that whether p and q are functions of x or x alone or constant, where p is what? P is sec square x. It is a function of x. And q is what? Sec square x into tan x. P and q must be functions of x or constant. If p and q are functions of x or constant, then this differential equation is linear differential equation of this type. Now, integrating factor I am going to find. E raised to power, what is the formula? Put value of p. P is what? Sec square x. And integral of sec square x is what? Tan x. Integral of sec square is tan x. Means e to the power tan x is our integrating factor. The only integrating factor may be asked as an MCQ. And once you get integrating factor, the find solution, what is the solution format for it? Solution of differential equation. Y multiplied by integrating factor, y multiplied by integrating factor is equal to integral q multiplied by, what is q here, see? Into integrating factor multiplied by dx. Okay. See, solution of differential equation is y into integrating factor, integral of q multiplied by integrating factor. Now it remains to find value of this integral, which is present on the right hand side. Now, the left hand side will be as it is. Y e to the power tan x equals, see, if you look at this integral or this function, see, derivative of tan x is present in the multiplication. But one more term, tan x, is also present. So what I am going to do, I am going to substitute tan x equal to t. Substitute tan x equal to t. If you substitute tan x equal to t, then derivative of tan is what? Sec square x dx. Derivative of t is what? dt. If you substitute tan x equal to t, upon substitution, its derivative must be there in the multiplication. Yes, sec square x is there in the multiplication. Okay, this is the valued substitution now. Now this integral, sec square x dx is dt. Tan x is as it is, which is t. E to the power tan x is like this. This right hand side is what? Integral of t e to the power t. Now evaluate this integral. Use integration by part. Here I am evaluating integral separately. So you can directly evaluate the integral or write the integral of t raised to power t. But if you want the explanation for this, I am going to give now. See, this is equal to, use integration by part. The generalized by part I am using. When we have the product of two, and in product of two function, one is algebraic function, then t square, t cube, or x square, x cube, x to the power n, like that, where n is positive integer. In that case, the generalized integration by part I would recommend. Now I am writing generalized integration by part. First function t, integral of second function, I am writing in the bracket, minus derivative of t here in the second term, which is 1, derivative of t with respect to t is 1, and integration of this bracket e to the power t is e to the power t. Plus minus sign occurs alternatively when you use generalized by part. The derivative of 1 will be what? 0. Then rest of the term will be 0. This series is being terminated here. The generalized by part I used. Now t e to the power t minus e to the power t is integral of this. See, integral of t e to the power t minus e to the power t. Now in degree level institutions, it's at degree level, so you can write down integration of this directly. Okay, no need to explain like this. Integral of t e to the power t is what? T e to the power t minus e to the power t. You can directly write in the examination as well. See, t is what? Finally, after integration, t is tan x. T is what? Tan x. Put t equal to tan x, and in the last step plus integration constant I am putting, and on the left hand side y e to the power tan x is also present. Okay, this is the solution to this differential equation. Now you can solve one more step, you can increase one more step also. You can multiply it by, this is not necessary, but you can multiply by e to the power minus tan x. So y is equal to e to the power tan x, e to the power minus tan x is equal to 1. This e to the power tan x will be removed, e to the power tan x will be removed, plus c into e to the power minus tan x. I have multiplied each and every term by e to the power minus tan x because e to the power tan x is present in 3 terms, but this step is not required. Okay, this is the third problem now. Here, solve cos x divided by dx plus y sin x equal to sec x. The cos x is there in the multiplication of dy by dx. We don't want it. The divide by cos x, that is to multiply by sec x. Dy by dx plus y sin x into sec x. Sec into sec x is sec square. Now, this differential equation is in the standard form now. Dy by dx plus py equal to q, where p is what? P is coefficient of y, and right hand side is sec square. Now dy by dx, one more step I have added, sin into 1 by cos means tan and sec square. Here this means p, this means tan, sin into sec is tan. So this is p, this is q. Then once you get p and q, then find integrating factor. The formula for integrating factor type 1 is e to the power integral of p with respect to x. Put value of p, then integral of tan is log of sec x, e to the power log of sec x is sec x, because here e to the power log of a is a. Okay, this is the relation between exponential and log. The integrating factor is what? Sec x. Once you get integrating factor, then standard format for solution you have to use. The y multiplied by integrating factor is equal to integral of q multiplied by integrating factor. Then integration occurs on the right hand side. Only right hand side we have to solve. Left hand side will be as it is up to the last step. Now integral of this sec x can be written as under root of 1 plus tan square, because this integral we have to solve. We don't have integral of sec cube x directly, sec square as it is. And if you look at this function, so integration or derivative of tan is present in the multiplication. Then substitute tan x equal to t, and consequently the derivative of tan is sec square x dx and derivative of t is dt. Means sec square x dx can be replaced by dt and 1 plus tan square means 1 plus t square because tan x we are substituting t. Now integral of under root of 1 plus t square, we have standard formula of integration. Under root of 1 plus t square or a square plus t square is what? T by 2 under root 1 plus t square plus a square by 2. Here a is 1. A square by 2 is 1 by 2. Log of t plus under root of 1 plus t square. Okay, this formula I have written here. Then after removal of integration, then substitute value of t. T is equal to what? Tan of x. So in this way we solve this problem. In this way we solve this problem. Now fourth one. 1 plus x square dy plus y minus tan inverse of x dx equal to 0. So if you look at this function very carefully, then this is not in the standard form. Then you try to bring it to the standard form. This term I have shifted on the right hand side. Then dy by dx I brought here. 1 plus x square I have taken it in the denominator. Then minus of y by 1 plus x square, separate denominator, minus y by 1 plus x square here, minus plus tan inverse of x by 1 plus x square. Now this term can be shifted on the left hand side because we want the differential equation in the standard form. Okay, we want differential equation in this form. See, dy by dx plus py is equal to q. Here q is what? Q is right hand side and coefficient of y is p. Here p is 1 by 1 plus x square and right hand side is q, tan inverse x by 1 plus x square. Now find integrating factor. Formula is integration of e to the power integration of p. Put value of p. Integral of 1 by 1 plus x square is what? Tan inverse of x. The integrating factor is what? E to the power tan inverse x. This integrating factor may be asked as an MCQ. Differential equation you will be given and you will be asked to find out integrating factor. And after getting integrating factor, they use standard format for solution of linear differential equation in y. What is the standard format? Y multiplied by integrating factor is equal to integral of q, tan inverse x by 1 plus q multiplied by integrating factor. The left hand side we have to carry it forward up to the last step. Integration is present on the right hand side only. If you look at this function, then derivative of tan inverse x is present in the multiplication. Derivative of tan inverse is what? 1 by 1 plus x square. Therefore, tan inverse x equal to t we are substituting. Okay, this substitution is always convenient when its derivative appears in the multiplication while integration. So tan inverse x derivative is 1 by 1 plus x square. Dx equals derivative of t is dt. Then we are evaluating right hand side. The integration occurs on the right hand side. So whatever changes due to substitution occurred, that should be written on the right hand side only. Then tan inverse x equal to t e raised to t into t. This is dt. This is what? dt. This is dt. Then integration of t raised to power t is what? t raised to t minus e raised to t. Using by part you can find out it. Or you can directly write in the examination. Integration of t to the power t is t to the power t minus e to the power t. And after integration, substitute value of t. T is what? Tan inverse x. I am putting t equal to tan inverse x, t equal to tan inverse x and c. This is the solution for this differential equation. Now the fifth problem. Solve dy by dx plus y by 1 minus x equal to x square minus x. Okay, this is very simple to recognize, This is the standard form dy by dx plus py equal to q, where p is coefficient of y 1 by 1 minus x and q is x square minus x. And you please check every time that p and q must be functions of x or constant. P and q must be functions of x or constant. That you have to check every time. Integrating factor e to the power integration of p. Put value of p here. Integration of 1 by 1 minus x is log of 1 minus x and derivative of 1 minus x is minus 1, that has to be written here. Then try to solve for one more step or two more steps. E to the power. This minus 1 can be brought here by law of indices. Then e and log will disappear and 1 minus x raised to power minus 1 is integrating factor, and this can be written as 1 by 1 minus x. This is integrating factor. Solution of the differential equation y multiplied by integrating factor is equal to integral of q multiplied by integrating factor. And try to simplify this right hand side integral. It is very clear that x is common and 1 minus x is as it is in the denominator. then x minus 1 can be written as minus of 1 minus x, because it is very clear to have the cancellation of 1 minus x. Then x is remaining, integration of x is what? X square by 2 minus sign is as it is. This is the linear differential equation in y we have solved. Next problem. Okay. 1 minus x square divided by dx equal to 1 plus xy. So this 1 minus x square coefficient of dy by dx we don't want. Therefore shift 1 minus x square on the right hand side, or divide this equation by 1 minus x square. We are dividing by, divide by 1 minus x square, divide by 1 minus x square. If you divide this by 1 minus x square, divide by dx will remain 1 by 1 minus x square, xy by 1 minus x square. Okay. Now this y term in dy by dx linear differential equation, the immediate next term must be the term of y. This term I am shifting on the left hand side, this is I am keeping on the right hand side. Now this is the standard form of this, dy by dx plus py equal to q, where p is coefficient of y. P is what? Minus x by 1 minus x square, and q is right hand side. Then integrating factor e to the power integration of p, putting value of p here, and this integral I have solved separately here. Integral of minus x by 1 minus x square, and if you look at this function very carefully, the derivative of 1 minus x square is minus 2x, which appears in the numerator. But for that we have to have the adjustment of 2. I am multiplying numerator by 2, dividing by 2, so as to get derivative of denominator in the numerator, minus 2x by 1 minus x square. Here denominator's derivative is present in the numerator, then integration of complete term is what? Log of denominator, 1 by 2 log of 1 minus x square, because 1 by 2 is outside. Okay, here I have written the integral of denominator 1 by a, and derivative of a is present in the numerator, and the integration of total term is log of a. In this way we have found the integration. Now integration of this term directly I am writing here. See, this 1 by 2 can be brought here at the index place of 1 minus x square, using law of logarithm. The e and log will disappear, then 1 minus x square raised to 1 by 2 is remaining, and 1 minus x square raised to 1 by 2 means what? It is under root of 1 minus x square, that is integrating factor. Write down the solution of the differential equation, y multiplied by integrating factor, integral of q multiplied by, this is q, see, multiplied by integrating factor, then solve right hand side integral is under root of 1 minus x square, 1 minus x square, therefore under root of 1 minus x square will remain in the denominator, and integral of 1 by under root of 1 minus x square is what? It is a standard formula, which is sin inverse x, and left hand side is as it is. In this way we solve this problem, linear differential equation in y. Now this try at your home to be discussed linear differential equation in y, or linear differential equation type 1. So we stop here. Thank you very much.